Okay, in this series of videos, I'm going to go over the Unit 4 review for your correctives. So, I'm just going to jump in and we're going to do probably through 13 here on the beginning. We'll see how we're doing after a little bit. So, given that triangle SQB is congruent to triangle MKV, list all 6 corresponding sides and angles that are congruent. You could draw the triangles if you want, if it helps you, if you're more visual, but you actually don't need them. So we'll start with sides. Sides have 2 letters, so SQ is congruent to MK. QB is congruent to KV. And SB is congruent to MV. That would take care of the 3 sides. The angles, a little easier. Angle S is congruent to angle M. Angle Q is congruent to angle K, and angle B is congruent to angle V. And we just look at the statement to make those congruence statements there. Write the congruent statement from this picture. Okay, so for here, we're just going to match up different things. I'm going to take this first triangle and I'm going to name it. So I'm just going to say AEB. So triangle AEB. You don't have to use that order. You could have said angle or triangle EBA or EADB. Doesn't matter how you say it, but what matters is the second one then. The second one has to be matching the parts on the first one. So what matches with A? Well, it's marked with a single arc. So a single arc is here, so that would be D. E is marked with a double arc. Double arc would be C. And that leaves B at the end. And there's your congruent statement of the 2 triangles. Okay. For 3 through 6, use the following diagram to tell what additional information you need to prove triangle BDA, so this one right here, is congruent to triangle FEC by the indicated method. So we know that these 2 are equal because they're right angles. We know BD is congruent to FE. That's only 2 things. We need a third. If I'm going to do this by HL theorem, what would I need? Well, HL theorem, I have the right angles. I've got a leg congruent. I would need the hypotenuses to be congruent. Well, what are the hypotenuses here? They're BA and CF. So what I would need BA to be congruent to FC. If I know that, then these 2 triangles are congruent by HL theorem. What about side angle side? Well, I have a side and angle. I need the side that's going to make that angle in the middle, and that would be this side here. So I would need AD to be congruent to CE. If I have that, then I would have side angle side. Angle side angle. Well, if I have an angle on a side, I need an angle that puts the side between the 2 angles. That would be here and here. So that would be angle, I have to use 3 letters here, angle DBA is congruent to angle EFC. If I have angle B and angle F congruent, then those are the 2 triangles congruent by angle side angle. And then angle angle side would be the other angle. So angle BAD is congruent to angle FCE. Okay. Kind of reversing that here. Use the following diagram. Each problem gives you another piece of information. So I've given you 2. I've given you the leg is congruent to this leg, and the angles are right angles. I'm giving you one more piece of information. With that, why are these 2 triangles congruent? It's one of the 5 shortcuts. So angle RTS is congruent to angle V. So our RTS would be this angle and this angle. Are congruent? Well, that would be angle, angle, side. Okay, erase that. Now if I'm giving you the ST is congruent to UV, right, then I would have side, angle, side. Angle R is congruent to angle VTU. That would be angle, side, angle. And then if I told you that T bisects RV, that means it cuts it in half, and that would mean these 2 sides are congruent, and that would be HL theorem. Okay. State why the triangles are congruent, and then give the congruent statement. So M is the midpoint of AB. I'm not actually having you do a proof here, but I'm going to kind of talk through it. It's kind of beginning of proof. So M is the midpoint of AB. That means that MB is congruent to AM, by the definition of midpoint. Now I can say that the two triangles are congruent because of side, angle, side. Side, angle, side. The congruent statement, I'm going to do the top triangle is triangle DBM is congruent to triangle CMA. Okay. Number 12, reflexive property says that side is congruent to itself. So the reason for this would be side, side, side. Now I'm going to give you a tip here. If you can't see side, 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 or you have a hard time with the congruent statement, something you could do, and I showed you this in class, is I'm going to redraw and label M, J, K, and I'm going to mark them the same way. So three lines, 2 lines, and a single line. And I'm going to redraw the other one. Don't have a ton of space, but I'm going to put the exact same markings in the exact same spot. So 2, 3, and 1. And now I just got to put the right letters from this triangle in the right spot. So so between the one with 3 markings and the one with 1 marking goes to M. So 1 marking, 3 markings goes to M. 3 markings, 1 markings, this is M. 1 marking, 2 markings goes to L. 1 marking, 2 markings, this is L. And then 2 and 3, that would make this up here, K. Now that can help me write the congruent statement. Triangle MJK is congruent to triangle. Now if I MJK, I went this way, I can go the exact same way when I redraw it here. KLM. Now, if you didn't need to do that, don't worry about it. If you can just write it from here, that's fine. That's just a thing that you could do if you're having a hard time. Okay? Next one, 13. Reflexive property again says Vy is congruent to itself. Now I can say that angle, that side is not between them, so it's angle, angle, side. So triangle VZY is congruent to triangle. Well, V matches up with V over here, so Z matches up with W, and then Y. And that's where I'll stop for this first video. Move on to proofs in the second video.